So welcome back guys. Here in this particular session we will be talking about the normal distribution curve. You know, the world, basically everything which we are talking about, it is actually coming in this particular curve, that is a normal distribution curve, right? This word is actually coming in this normal distribution curve. You can actually talk about anything and it will be following the normal distribution curve probably, right? So here, this is a very interesting chapter guys, normal distribution curve, right? This is a bell curve, as you can see over here, right? This is the curve over here which we are talking about, and this is the normal distribution curve, right? In reality, if you talk about guys, it is never touching the baseline. It is never touching the baseline. However, it might be seen that it is touching the baseline, but that is not the case in reality. So it is never touching the baseline guys. This is having which shape? This is having the bell shape. This is the bell shape curve, right? Already itself is having the MCQ, that normal distribution curve is which shape? That is the bell shape curve, right? So this shape is particularly called as a bell shape, nothing new in that, right? This is the bell shaped curve. Guys, you know, here they are writing the world tends to be bell shape. Yeah, that is a true statement over here, because you know everything is actually lying in this particular normal distribution curve. And if you talk about the center of this particular normal distribution curve, if I'm talking about the center of the normal distribution curve, most of the events, most of the things are surrounding that central only, right? For an example, let me give you an example over here, right? Let's say there are 100 students in a class, right? There are 100 students in a class, and on an average there are some students who are getting very low marks, right? But usually they are not more, right? Usually how many out of 100? It might be 15 students who are getting very low marks. I mean, out of 100 paper, out of 100 marks, they are getting just 10 or 20 marks. There are some, again, few students who are getting above 90 marks, right? There are very few students who are getting less than 90 marks or less than 20 marks. There are very few students who are getting more than 90 marks out of 100. But most of the people are getting the marks around, if it is from out of 100, from 60 to 80, right? Or I would say 50 to 80, that would be the range that most of the students, right, they will be getting the marks. Or I can write it like 40 to 80, that they will be getting the marks in between this range only. So that particular 40 to 80 range will be coming in this area, right? And the student who is getting marks above 90, let's say there are 4 students only, they will be coming over here. And who are getting very less marks, they will be coming over here. I mean, majority will be coming around the central part of the normal distribution curve, and total 100 will be here to here, right? Total 100 students will be coming here to here. I just gave you the example guys so that you understand the power of it, the normal distribution curve, right? So over here they are saying you that most outcomes are occurring in the middle. You know, in the middle we are naming it as mean. In the middle we are again talking about the mean, right? Measure of central tendency. So mean over here. Now, you know, if you are going away from the center, right? They are going away from the center, then we are talking about the deviation from the mean, deviation from the center, and we are calling that as standard deviation. If you guys remember, I told you in the measures of variation, I told you that there is range and there is a standard deviation, and other than that I told you about other things also. So I told you about the formula for the sample and the population size as far as standard deviation is concerned. But here, what is the standard deviation? In this particular session I will be talking about that. So you know, if you are actually deviating from this particular central line, either left side, either right side, this is called as the standard deviation. This is called the deviation basically, right? Usually we are saying that you are deviating from your path. You are not in your right path, right? You are not preparing well, you are deviating towards anything else, right? So that is the thing. So deviation is there, right? That is called the standard deviation. So let me tell you in itself what is the normal distribution curve, right? What is the normal distribution curve? So guys, we shall be writing some points over here which is very relevant for our topic, that is the normal distribution curve. If we talk about this one, you know, this is the most common shape which is taken for this normal distribution curve. Most common shape which is taken, this is taken by continuous data distribution, right? So it is the most common shape which is taken by the continuous data distribution. We can talk about any kind of data and just put it in the normal distribution curve, isn't it? Right. Now this is also known as, guys, it is also known as bell-shaped curve. It is also known as bell-shaped curve over here, or bell curve, right? It is also called as the Gaussian curve or Gaussian distribution. It is also called as Gaussian curve or Gaussian distribution. One more important point, I told you that ends of this particular curve, ends of this curve never, right, never touch the baseline, right? Ends of this curve will never touch the baseline. That's why I wrote it in the bold letters, right? Next point over here, which I would like to mention over here, that if you talk about the parameters over here they are having the two parameters. One parameter is the standard deviation. One parameter is the mean, I told you, that is in the center. And if you deviate it either on the left side, either on the right side, it will be called as deviation. That is called as the standard deviation. That is called as the standard deviation. It is abbreviated very commonly as SD, right? That is SD. That is the standard deviation, right? One more thing. Usually this curve is the symmetric curve. Usually this curve is the symmetric normal distribution curve, right? It is having the bell-shaped. Yes, that is the bell-shaped curve, right? Bell-shaped curve. Having a single peak over there, right? Having a single peak over there. This is called as the peak of the normal distribution curve, right? So this is called as the peak of the normal, having single peak, right? So these are some features of the normal distribution curve, right? One more thing over here I would like to mention. What is the area under curve? AUC is the area under curve. Area under curve, we are generally considering it as 1. We are generally considering it as 1. What is the area under curve? This particular area, area from here to this particular whole area, which I am showing you with the blue color, that is the area under the curve, right? I am showing you it with this area, right? This particular area which is covered, right? The whole graph which is covering by that, right? That is the area under the curve, and we are considering that as area under the curve. We are considering that as 1. Okay, so no doubt about it. Okay, one more thing over here, that the frequency of values which we are talking about over here is more around the center but less around the periphery, right? Over here also you can say, right, you can see what you can see over here, what you can see over here. Okay, I'm just removing it so that you are seeing that very clearly. I can see that most outcomes are occurring in the middle. Look at my pointer over here. Most outcomes are occurring in the middle, and if you will be going towards the periphery, right, if you will be deviating from the center, if you are going towards the periphery, for example this side, if I am talking about, fewer in the tails. So most outcomes are occurring in the middle and fewer are happening in the tails, right? Fewer happening in the tails, and even very rare outcomes are possible outside this normal distribution curve. So most of the events are happening towards the center, as I told you, as I gave you the example of students in the classroom about their marks, right? Most of the students are getting the marks in the middle range only, right? But there are few students who are getting very poor results, and there are few students who are getting very, very good results, very impressive results, right? So that is the thing. So, and very few students would be there that who are getting just 1 mark, or who are getting just 100 out of 100 marks, right? So even maybe 1 or maybe 0, right? Usually their chances are 0, but usually still some student can be there who might be getting the 100 out of 100 marks. So that would be the kind of a just sitting on the tail of the normal distribution curve, just sitting over here or just sitting over here, right? But having very few chances. Otherwise most of us are actually lying towards the center only, isn't it? So that is the thing, right? So over here also in the exam pattern also, generally what we are seeing, most repeated questions are having very high chances of coming in the exam, or the most repeated topics are having very high chances, are having very good chances of repeating in the upcoming attempt as well. So that's why those kind of questions will be coming towards the center line of the normal distribution curve. And the questions which are very, very rare, right? Questions which are very, very rare, the topic which has been asked 10 to 15 years back. So that topic probability, coming into the chance is very, very low, right? So that particular question, these kind of topics will be coming in the tails of this normal distribution curve, right? I'm just giving the example. So anything can be fitting into this normal distribution curve, right? Once you understood this, one more point over here I would like to mention that there is no skew in the curve. What do I mean by skew in the curve? However, we will be talking about that separately, guys. No skew in the curve. No skew in the curve means you are seeing that curve, how the curve is looking. The curve is looking like this, you know, the curve is looking like this, right? And the ends are never touching the baseline. I told you already. Area under the curve, I told you, that is equal to 1. Okay, so no doubt about that. Area under the curve, that is equal to 1. But still, guys, what I'm saying over here is, the point over here is, my point is that if I'm saying there is no skew over here, right now there is no skew. I'm not seeing any kind of skew over here. I'm not seeing any kind of skew. But when I will be seeing the skew, when my normal distribution curve will be going towards either one direction. It might be going towards either this direction, it might go towards either this direction. For example, I am drawing the graph and I am saying this is my graph, and my normal distribution curve is going like this. My normal distribution curve is going like this, right? Or my normal distribution curve is going like this, right? So this is called as the negative skew or the left-sided skew, right? And this is called as the positive skew or the right-sided skew. But for now, this is not my point of discussion. This I will be discussing in the separate session, right? Don't worry about that. About the skew, I will be taking the separate session. But for now, I am just showing you that neither the normal distribution curve is showing the positive skew, neither it is showing the negative skew, right? It is not showing the skew. It is having the symmetrical bell shape. It is having a symmetrical bell shape, and that you need to understand. And that was my motto, to make you understand that what I am talking about, right? Once you are clear with that, right? Once you are clear with that, now we have understood that what is the normal distribution curve. Once again, guys, come on. We have understood that it is having a normal distribution curve, is having what? In the center, most of the events are occurring towards the center only, and very few events are occurring towards the tail of the normal distribution curve. This is called as the tail of the normal distribution curve, and this is called as the center of the normal distribution curve, isn't it? Right. One more thing over here, we came to know that, you know, this is called as the peak of the normal distribution curve. It is having which shape? It is having bell shaped. The area under the curve, which is covered under the normal distribution curve, we will be considering that as 1, right? Along with that, is it having any kind of skew? Is it having any kind of pattern like towards the left side or right side? No, it is having symmetrical shape, having the bell shaped curve. Area under the curve will be 1. It is not showing any kind of skew over here, right? So these are important points. What factors we are showing? In the center, we are showing the mean. In the center, we are talking about the mean, and towards the periphery, we are talking about the standard deviation. Towards the periphery, we are talking about a standard deviation. For an example, what kind of standard deviation I am talking about? Let me take you to this particular diagram. Here in the center, we are taking the mean. In the center, we are taking the mean, and most of the events are occurring towards the center only. When you will be going towards either direction, either towards the left side of the curve, either towards the right side of the curve, then you are deviating from the path, deviating from the center, and that's how they are talking about the standard deviation, right? And standard deviation, they have talked about either if you are going on the negative side, then it could be -1, -2, -3. And if you are talking about the right side, then you might be going for the +1, +2, +3 standard deviation, right? So here also we are seeing that same situation, that on the right side if you are going, then it is the +1, +2, +3 standard deviation. SD means standard deviation. If you are going on the negative side, right, left side, then it will be the -1, -2, -3 standard deviation likewise. Now, one important thing which you need to remember over here, guys, for the normal distribution curve, very frequently asked in the MCQs as well, and the point is, you know, if you talk about the area between the -1 and the +1 standard deviation, -1 and the +1 standard, what I am talking about is from the mean, here would be the -1, here would be the +1. So between this thing, area under this particular curve, that is the -1 to +1, here this will be having how much amount of data? 68.3%, and approximately I can say around 68% of the data. So they are asking you that how much is the data covered, how much is the area covered under the if the value is between -1 and +1 standard deviation, then it is the 68%. If it is between -2 and +2, then it is increasing, then it is 95.5%, it is almost 95%. And if it is between -3 to +3 standard deviation, then in those cases we are talking about 99% of the data is covered, right? And area under the curve I told you that is almost around 1. Area under the curve I told you that is in total that is 1, right? So I am telling you that between the -1 and the +1 standard deviation, we are saying that 68% of the data is covered approximately. -2 and +2 standard deviation, we are saying almost around 95% of the data is covered, and -3 and +3 almost 99.7% or around 99% of the data has been completed. For an example, I can give you the example also, guys. In a class of 100 students, I told you that most of the students are getting the marks between 40 to 80 or 40 to 70 or 40 to 80, right? That is a range, right? So 40 to 80 range is getting the marks toward the center, right? So most of the events are happening towards the center of the normal distribution curve. There are very few students who will be getting the marks above 90 and less than 10 or less than 20, right? So they will be coming in the tailing part of the normal distribution curve, but still, right? So now these students might be coming in this category, and the student who got 100% of the marks, or who got 99 marks, or who got 1 or 2 marks only, they will be coming in this category, right? But right, so here between the -3 and +3, almost 99% of the students might be covered of the class, right? So that is the thing which I am talking about, right? So most of the events are occurring toward the center, very few events are occurring away from the center or towards the tail of the normal distribution curve. Once we have understood this particular info, now we shall move on to the next particular important topic, that is the zone of normalcy. Zone of normalcy. Everything is same, guys. Once we have developed this particular basic foundation of the normal distribution curve, now it will be very easy for us to understand what is the zone of normalcy. Zone of normalcy is also called as the normal zone. It is also called as the normal zone, right? Please remember that, between -2 and +2 standard deviation, what I am talking about, between -2 and +2 standard deviation, we are calling that particular zone as normal zone or the zone of normalcy. So I am just highlighting that area between -2 to +2 standard deviation, right? We are covering this area, we are covering this area, and we are calling this area as zone of normalcy, right? Between -2 and +2, right? So this is called as what? This is called as zone of normalcy or normal zone. Okay, first thing is clear. Between -2 and +3, we are -2 and +2, we are considering that as zone of normalcy. But if some data will be covered outside this zone, either on the negative side, either on the positive side, right, beyond +2 standard deviation or beyond -2 standard deviation, that will be considered as abnormal area, abnormal zone. Are you understanding this? Now on the basis of that, right, so normal zone is present in between -2 standard deviation to +2 standard deviation. Okay, please do remember that. Once we are clear with that, now we shall be moving on to one more topic, that is the z-score. Now what is this z-score, guys? Z-score, it is also known as the standard deviation, or it is not the standard deviation, I will call it that as standard deviate. It is also called as the standard deviate. It is also called as the standard deviate, right? Standard deviate is actually giving us the location of the value in terms of standard deviation, in terms of standard deviation. So z-score is giving us that particular value in terms of standard deviation, gives the location of the value in terms of standard deviation. For example, z-score might be coming in this range, z-score might be coming in this range. If it is coming in this range, then it will be called as abnormal zone. If it will be coming in this range, then it will be called as normal zone. Are you understanding this particular thing? Very easy, guys, till now, right? Now cutoff for this, right, cutoff for the z-score is also given. Now cutoff for this z-score is given, that is ±2 standard deviation, or to be very, very specific, if you will ask, then it is ±1.96 standard deviation. If 1.96 is given, then that would be the answer. If it is not given, then 2 will be the answer. At least 2 will be given in the options, then that could be the answer. Overall, generally, you might remember ±2 standard deviation, because we are considering the normal zone or zone of normalcy in between the -2 and the +2 standard deviation. Are you clear with that, guys? Yes. Now let's say I am saying that if Z score is more than 2, if Z score is more than 2, I mean I am going beyond my normal zone. I am going beyond my normal zone, and I am saying that I am talking about Z score more than 2 means over somewhat over here, or it might be here, but it is beyond this range. So it is coming in the abnormal zone. So if I am saying if Z is equal to Z score is more than 2 or Z score is less than 2, right? If I am saying Z score is more than 2 or Z score is less than 2, then in both the cases this is called as abnormal. This will be called as abnormal Z score. Obviously this, in both the cases, this will be called as the abnormal Z score. Abnormal Z score, isn't it? Why is it so? Because I told you -2 to +2 is the normal zone, right? It is the zone of normalcy. Anything beyond +2 or anything beyond -2 will be considered as abnormal zone, right? And Z score is representing it is giving us the value in terms of the standard deviation, right? It gives location of the value in terms of the standard deviation, that the value is presenting outside the standard deviation or how much it got deviated, right? So that is about the Z score, right? So that was about the normal distribution curve, guys. I hope you enjoyed the topic. Revise it once again and try to solve the MCQs regarding that, right? Thank you.